Let's have a look at exercise 5C. In your textbook, it's on page 220, and your lesson plan today asks you to consider question 1, A, C, E and G. E and G. So why don't we do the other ones? Okay, so that means we are going to have a look at B, D, and F. Let's do that. Okay, B. Now what's the question? The question says, for these pairs of events, state if they are mutually exclusive, independent, or neither. Okay, so let's have a look at the page of formulas that precedes this exercise. And this is the one we looked at in our previous video. It's quite comprehensive. It looks at mutually exclusive, independent, dependent, and complementary events, and has some conditional situations up here. Okay, so we said we're going to have a look at B, D, and F. Okay, well, let's have a look at B. B is C. The event C is it rains tomorrow. And event D is it rains today. Okay, and what we need to do is to decide what it is, if it's mutually exclusive, independent, or neither. Let's look at mutually exclusive first. Mutually exclusive says two events A and B are mutually exclusive if they cannot both occur. Well, these could both occur, so we know it's not mutually exclusive. All right, now it's possible that you may not be able to see this in the video. If not, just have a look at your textbook on the previous page. You see it there. Okay, the other thing we need to check is independence. So two events A and B are independent if the occurrence of each event does not affect in any way the occurrence of the other. But if it does rain today, then it's more likely to rain tomorrow. So these are not independent. They are dependent events. Remember, if they're not independent, they're dependent. Okay, so the answer of this one must be the third choice, which is neither. Let's look at D. Now D is pretty straightforward, because there are two dies here. Throw a prime number on a fair die and throw an even number on another die. Well, if we look over here, we can see two events A and B are independent if the occurrence of each event does not affect in any way the occurrence of the other. So on one die, throwing a prime number does not influence at all the throw of an even number on the other die. Okay, they're two separate events there. So D is independent. Let's have a look at F. Now F says M is you choose a number at random from 1 to 10 that is no more than 5, and H is choose a number from the same set that is 4 or more. Well, choosing a number at random from that set, those 10 numbers, that is no more than 5, okay, means that it's 1, 2, 3, 4, or 5, because it's no more than 5. So it's the probability of that is 5 out of 10. So we can represent that by putting the probability of M equals 5 on 10. Now the probability of H, the event H, now that's defined as choose a number from the same set which is 4 or more. Well, if it's 4 or more, it is not 1, 2, and 3. So that's 7 out of 10. Okay, now this is F. So if we have a look at it, we know that the union, the intersection of these two, the probability of the intersection of M and H, the events M and H, intersection, is going to be 2 out of 10, because it's only the numbers 4 and 5. So therefore, if it is just 4 and 5, that's 2 numbers out of 10, so that's 2 over 10. Okay, and from the yellow box of formulas from the textbook, we know that for an independent event, to check whether it's independent or not, the probability of the two events, the intersection of the two events, should equal the individual probabilities of each event multiplied by each other. So let's write that for our case. What we're saying is that the probability of M, the intersection of MH for an independent event should equal the probability of M times the probability of H. Let's see if that's true. We know that that's 2 on 10. Okay, that comes from here, 2 on 10. The probability of M is that one, probability of H is that one. So probability of M is 5 on 10 times the probability of H is 7 on 10. That equals 35 on 100. And it's clear that the left-hand side does not equal the right-hand side, so they're not independent. They're not mutually exclusive because there exists an intersection. So that means the answer for number F must be neither. The answer is neither.